All right, today we're going to do something a little different. We're moving beyond just writing code. We're going to step into the shoes of a system architect. We're going to build that mental model you absolutely need to design systems that can scale to millions and millions of users. Think about it. You click buy, you see a little loading spinner for a second, and boom, your package is on its way. But behind that one simple click, well, there's this hidden world, right? A complex, beautiful architecture that makes the entire modern internet even possible. And we're about to pull back that curtain. And believe it or not, these massive, globe-spanning systems, we're talking Netflix, Uber, Amazon, they can all be broken down into just 16 fundamental pillars, 16 core concepts. And once you get them, I promise it will completely change how you look at software. Now, what we're covering here isn't just theory, okay? This is the practical roadmap that separates junior developers from senior architects. Honestly, this is the key to acing those really challenging system design interviews. Okay, let's start the journey. We're going to follow a single click from the moment it leaves your device to the second you get a response back. First up, the edge of the system. This is where your request meets our gatekeepers for the very first time. So this first leg of the journey, it's like a three-step dance that happens in just milliseconds. Your request goes from DNS, which is kind of like a phone book, to a CDN, our local warehouse, and then finally to a load balancer, the system's traffic cop. Let's break down each one. First up, DNS, the internet's phone book. You type in a name you can remember, like Amazon.com, and it finds the correct IP address, the server's actual number. Mastering this is all about crushing latency. For example, you can use geolocation routing to send users to the server closest to them, making everything feel almost instantaneous. Next, your request hits a CDN. Think of it as a whole network of mini warehouses storing stuff that doesn't change much, like images and videos. This is the secret sauce to a snappy global product. I mean, a well-configured CDN can offload up to 90% of the traffic from your main servers. That's huge. That's the difference between a smooth Black Friday and a complete site meltdown. And finally, the request arrives at the load balancer. I love this analogy. It's our system's traffic cop. It intelligently distributes that flood of incoming requests across all our servers, making sure no single one gets totally overwhelmed. This is your first line of defense for high availability. And knowing the difference between a simple Layer 4 balancer and an intelligent Layer 7 one, well, that's absolutely critical for stopping bottlenecks in their tracks. Okay, so our request made it past the gates. Now we're inside the application where the real work happens. This is the system's brain. It's where all the data lives, and more importantly, where we need to get to it at lightning speed. The first big decision, and this is a classic interview question, is SQL or NoSQL. The core trade-off is really this. SQL gives you structured data with super strong consistency. Think bank transactions that have to be perfect. That's thanks to something called ACID properties. NoSQL, on the other hand, gives you incredible flexibility and availability, which is perfect for something like a social media feed. That's base properties. Choosing the wrong one here can pretty much doom your system from the very start. And this quote just highlights a common mistake, a real architectural sin. You wouldn't store a movie file in a spreadsheet, right? Of course not. The exact same logic applies here. Relational databases are just terrible at handling huge, unstructured files. And that's exactly why we have blob stores, like Amazon S3 or Google Cloud Storage. This is the right tool for the job. It's a specialized service designed from the ground up for storing massive, unstructured things like photos, videos, and log files. It's built for pretty much infinite scalability, and it's incredibly cost-effective. But even the best database in the world can become a bottleneck if you hit it with too many requests. And that's where caching comes in. Think of it as this ultra-fast speed layer that just lives in memory, holding on to the answers to common questions. This stops you from having to bother the main database every single time, giving you that sub-millisecond response time that users just expect these days. So we have all these different pieces, servers, databases, caches. They're all doing their jobs. But how do we make them talk to each other efficiently and reliably without creating, a tangled mess of chaos? This is the system's nervous system. Now we need to get our services talking. There are two main patterns for this. For one-to-one tasks, like sending an email confirmation after you buy something, we use a messaging queue. But for one-to-many broadcasts, like telling multiple services that a new user just signed up, we use a publish-subscribe system, or pub/sub. Really understanding this distinction is the foundation of any modern microservice architecture.
As our system gets bigger, we need another gatekeeper, the rate limiter. This thing is so essential for security and stability. It prevents denial of service attacks, and it stops that one noisy neighbor, one super active user, from hogging all the resources and crashing the system for everybody else.
Okay, here's a component that's often overlooked but is absolutely crucial for services like Twitter or Instagram: the sequencer. In a big distributed system with tons of servers, a simple auto-incrementing ID just won't work. A sequencer is a specialized service that generates unique, time-sortable IDs, making sure everything always shows up in the correct chronological order. So, we're building our system with all these powerful components. It's getting pretty cool. But once it's up and running, how do we know if it's actually healthy? How do we spot problems before they cause a huge outage? Well, this is where observability comes in. It's the architect's eyes and ears. Without these three, you are flying completely blind. Seriously. Logging is your system's black box, a detailed record of every single event, which is vital for debugging. Tracing lets you follow one request as it hops through dozens of services, so you can pinpoint the exact bottleneck that's slowing things down. And monitoring? That's your real-time health dashboard, the eyes that tell you to scale up before the whole site crashes. And finally, let's quickly cover two powerful workhorses. First, you have distributed search engines like Elasticsearch. These are essential for building features like fuzzy text search or product recommendations that a normal database just can't handle. Second, distributed schedulers. These are the super reliable way to run background tasks. Think send a report every Monday at 9 a.m. across a whole cluster of machines without ever worrying if one of them fails. And this brings us to what I think is the most crucial point of all. After learning all 16 pillars, the goal is not memorization. It's about understanding the trade-offs. The expert architect isn't the one who knows the most buzzwords. No way. It's the one who can clearly explain to you why they chose a messaging queue over a pub subsystem for a specific problem. It's always, always about the why. So there you have it, the blueprint. You now have the 16 fundamental building blocks of the entire modern internet. The only question left is, what are you going to build with them?